Hello and welcome back to our First Flight kickoff streams. These kickoffs are an opportunity for you to get insight into the code base before you try and find some of those vulnerabilities. The First Flights are mock tests for competitions, I'd say. So they're opportunities to look at simple code bases and find vulnerabilities, submit them on a competitive audit platform, and learn how to improve during that process. So there's no funds to be earned, but there are XP points to be earned, and they give you an opportunity to learn from other auditors within the community and better yourselves before you do go on to those competitions where you can earn real funds. Now, if you have any questions during this stream, please do fire them in the live chat. And if you have any questions later on, then head over to our Discord, which is linked in today's description. And there will be a channel open specifically for this week's First Flights, where there will be other auditors like you learning and wanting to submit vulnerabilities. So ask your questions in there and help others in the community to better themselves and become an auditor. Now, for those of you that have completed Updraft and gone through those educational courses over on Updraft, First Flights are really the next step to take. As I said, giving you that hands-on experience of creating a submission for a competitive audit, but with a simpler code base to help you learn and evolve before you really go on to those real-life competitions. The First Flights competitions launch every other week. So this week we have Eggstravaganza launching. This is First Flight number 37, and this is actually a submission from an auditor within our community. So if you would like to contribute to First Flights, perhaps you've entered a couple of First Flights competitions by now and you're looking to give back to the community, then please do let us know, and maybe your repo can be used as one of the next couple of First Flight competitions. You will get some credit for that over on our Twitter and social platforms as well when we're marketing the First Flight. So if you are interested, let us know over on Discord and we can hopefully get you involved in this process. But let's get into it now. Let's get into First Flight number 37, Eggstravaganza. Let's see what this repo is like for this week. We will be talking through the repo. We'll be looking at the different functions, just really giving you some guidance as to what this repo does before you do try and find some vulnerabilities throughout it within the next week. So this competition launched yesterday at midday UTC, and it is live until next Thursday. So you've got 6 more days to dig into it and submit those vulnerabilities on the CodeHawks platform. Taking a look at how the CodeHawks platform works, all you need to do is go to codehawks.cyphering.io. If you go filter to First Flights, you can see this is the First Flight, which is live at the moment. And this shows us some information about the repo itself. So let's take a look at this. First of all, we're looking at 129 lines of code, so not too many here. This is a brilliant place to start if you're new to the competitive audit space. We have a little bit of information about the project here. So EggHuntGame is a gamified NFT experience where participants search for hidden eggs to mint unique Eggstravaganza Egg NFTs. Players engage in an interactive hunt during a designated game period, and successful egg finds can be deposited into a secure egg vault. So there are 3 different contracts that we'll be looking at. As you can tell, we only have 129 lines, so they're not too big here. But this is the perfect opportunity to practice and get involved in the competitive audit space. Now, there are 3 actors for this protocol. We have the game owner, so this is the deployer and the administrator, the person who starts and ends the game and adjusts the game parameters and manages the ownership. We then have the player. So this is a participant who will call the search egg function and try and mint some NFTs upon successful searches, and they can choose to deposit their egg NFTs into the vault if they wish. And finally, we have the vault owner, so the owner of the egg vault contract responsible for managing deposited eggs. This will all make a lot more sense when we go through and actually take a look at those contracts. So let's do that. And if you just click view repo here, you will get pulled up to the repo on the CodeHawks platform. And if you go into, well, first of all, you can take a look at the README and see what's involved in the README. A lot of this will be similar to what we've just discussed. You can then read the build setup instructions over in the getting started section. So it's a Forge build process and then Forge test. Have we got any known issues? No, we do not. None have been reported. So it's a plain field. You can go and find what you can and submit them on the CodeHawks platform. and the scope is, of course, all of the 3 contracts that we're looking at within this repo. So let's get started. Let's take a look. Let's take a look at these contracts. I think it makes sense to start with the Eggstravaganza NFT contract. So this is a standard ERC 721 contract. Nothing too complex here, but we will run through it quickly. So just pulling this up, make sure we can see everything. Everything's looking good. So we have, first of all, we are importing Open Zeppelin contracts, the ERC 721 and the ownable contracts. And then we're getting started with our contract. So we are creating a public state variable called game contract. So this is the address of the game contract, and we will limit later so that only the game contract can mint these NFTs that we're creating here. We then have the next state variable, which is public EUINT 256, and this is the total supply. So this is the total number of minted egg NFTs. Next, we're going into the constructor. So this is the function that is called upon deployment. It's initialized. So when we are deploying the contract, we are going to define the name of the NFT and the symbol for the NFT, and they are going to be in the constructor there. We then move on to the set game contract. So this is where, as I said earlier, we are going to limit who can mint these egg NFTs, and we're going to limit it to the game contract. So another contract that we've deployed as the protocol deployer. So this function is going to set the game contract state variable to the address of the EggHuntGame contract. And then when we are in the mint NFT function, we are going to ensure that the message sender, the person calling the function, is that game contract that was defined throughout this function up here. So that is the Eggstravaganza NFT contract. It's pretty simple, just a standard ERC 721. It allows us to name our NFTs. It allows us to give them a symbol. It has a variable that tracks the total supply of the NFTs, and it limits who can NFTs to just the game contract that we have also deployed through this protocol. So let's carry on then, and let's take a look at the next contract. I think it makes sense to move on to the EggHuntGame contract first. So this is the actual game that we're looking at, this Easter egg hunt that we're doing here. So this contract is ownable, and we are going to set some state variables before we get involved in the contract. But essentially how this will work as a game is we have a start, we have an end to the game. So we'll have the game duration set as well, and we will have a threshold. Now, to play the game, the user will call the play function, and they will be generated a random number between 0 and 100. If their number is lower than the threshold that has been set for that game, they win and they get to mint an NFT. If their random number is higher than that threshold, then they lose and they do not get to get that NFT. Now, when we're setting the threshold for this, obviously the lower the threshold, the less likely a user will be successful and the less likely an NFT will be generated. I think that understanding is important when we're looking through these state variables here. So the first state variable we have is the minimum game duration. It is set to 60 seconds here. We then have the start time, the end time, and whether the game is active is a Boolean here. All of these variables will be changeable. Next, we have, we're going to reference the Eggstravaganza NFT contract and the Egg Vault contract, which we'll look at in a second. Next, we have some mappings here. So we're going to map from so it tracks the number of eggs found per participant. So if I start to search for eggs over and over again, and I'm successful multiple times, this mapping needs to track that. So it'll take my address and then show how many eggs I've found within that game. And we have the global counter for minted egg token IDs. So this is how many eggs have been minted and their IDs. Next, we are looking at the egg find threshold. So this is set to 20 at this as default here. This is the figure that I said is the threshold, and this is the number that we're hoping our random number is below in order for us to find an egg and then an NFT. So with it being 20 here, the default is a 20% chance of people being successful and being able to win the game and mint their NFT. If the threshold is lower at 10 and we're generating random numbers between 0 and 100, then we're only offering a 10% chance of winning the game and minting an NFT. So this is default at 20, but it is changeable. Moving on to some events that we will be calling throughout this contract, we've got the game started event. This has the start time and the end time. Then we've got the egg found event. So this will show the player, the token ID, and the total number of eggs found. And we have the game ended events. This will just show the time at which the game has ended, and we will be calling them throughout the next couple of functions. So let's take a look at those. First of all, we have the constructor. Now, the constructor takes the address of the egg NFT and of the egg vault, the egg NFT contract and the egg vault contract. And it will make sure that they are not the 0 address and make sure they are valid addresses. We will then define the addresses as those contracts that have been called earlier on, imported up here. Moving on, then we should all be set up to get started and start to play that game. Now the constructor has been set and initializes the game with the deployed contract addresses from the other 2 contracts that we're going to be relying on during these functions. Let's take a look at how this game works then. So we have the start game function. This will check that there's not a game that's already active, checking that Boolean that we defined earlier on. And we will require that the game is not too short. So we'll set a minimum game duration variable. So let's see where this was higher up. Here we go. So it's 60 seconds. So we'll make sure that the game is at least 60 seconds duration. Otherwise, it's just too short. We will then have the start time and the end time set. As those variables that we defined up here are now in use. So the start time will be the current block timestamp and the end time will be the block timestamp plus the duration that has been set. And then we will change the game active Boolean variable to true. Finally, within this function, we will emit the game started event. So we'll have the start time and the end date there. Next, we have the end game function. So this is, once again, only allowed to be called by the owner. So this will require that the game is already active, and this function will check that here. We will then change the game active variable to false, and we will emit the event game ended here. So there's the start game and the end game functions. But let's take a look at how we can change some of those variables and how we can actually take part in this game that we've now set up. So first of all, we can set the egg find threshold with this function here. So we can change the threshold. As I said, the game will involve users generating a random number between 0 and 100 and hopefully finding a number that is lower than the threshold in order to be allowed to mint an NFT. With the default threshold being at 20%, there's a 20% chance that users will be successful and earn those NFTs. But this threshold is changeable. So we may want to make it easier and bump it up to 50, or we may want to make it harder and bump it down to 10. This function allows us to do that. So this function is only allowed to be called by the owner, of course, because we don't want users to change the threshold to 99 and make it super easy to mint NFTs. And so the owner is the only person that can call this function. And we can create a new threshold here that it must be below 100, of course, to make sure that it's still a game involved. Moving on to the next function here. We have the search for egg function. So this is the one that users can call. And this is where we are trying to generate a random number lower than that threshold. So let's walk through this line by line. First of all, we are going to require that the game is active. So the game active variable is true. If not, we are going to omit the game not active here. Next, we are going to require that the current time is later than the start time for the game. Then we are going to require that the current time is later than the end time for the game. Both of those variables, start time and end time, have been defined during that start game setup, and the variables are state variables, so it's stored up there. Next, we are going to generate the random number. So using this random number generator, which takes our block timestamp and our address and the contracts, we're going to generate a random number, and we are then going to test to see if it's below the threshold. So if we are successful and our random number is, well, first of all, our random number, we're going to generate the random number, then we're going to use the modulus 100. So this is going to make sure that our random number is between 0 and 100. And we are then going to test to see if our random number is lower than the threshold. So if it is, and we've been successful and we have found an egg, then we are going to increase the egg counter by 1. We are going to increase the number of eggs found through the mapping that we discussed earlier up here to 1. So this tracks the number of eggs found per participant. We're going to take our address and we are going to increase the value that's stored there by 1. So if it's our first egg that we've found, this mapping should return when given our address, number 1, through this change here, through this increment change here. Next, we are going to mint an egg. So we are using the egg NFT contract here, and we're going to mint that egg, and then we're going to emit the event to say, yeah, the egg has been found, and we have minted an egg there for the user. Next, we are going to take a look at this function here, which is to do with the vault, and we will be taking a look at the vault contract next. So this function allows us to deposit eggs to the vault. It takes the token ID. Essentially, what we need to do is send the egg NFT to the vault. So it allows the player to deposit their egg NFT into the egg vault. First of all, we're going to make sure that the owner of the token that's being sent is the message sender, and the player must first approve the transfer of the NFT contract. So the egg NFT transfer from egg vault deposit egg there. So those functions will be called, and we'll deposit the egg into the vault, which is the next contract we'll be looking at. Moving on to just the quick two view functions at the end of this contract before we do get onto that vault. First of all, we have the get game status. So this is going to see if a game is active or not. How we are going to do this is we are going to check if the current time is less than the intended start time, then the game's not started yet. If the current time is more than the intended start time and less than the intended end time, then the game is active. And otherwise, so if the current time is after the end time, then the game has finished. Finally, else the game is not active there as well. So this is just a bunch of ifs, if else's, just to check whether the game is active or not, depending on the current timestamp and the start timestamp and the end timestamp. And there was a little bit of a tongue twister. Next, we have the final function in this contract, which is get time remaining. So this is just going to take a look at the current timestamp. We're going to take a look at the end time, and we're going to do a little bit of math there to calculate how long's left. So the end time minus the current time will tell us how many seconds are remaining in this game. So that's the egg hunt contract. It looks like we don't have any questions in the chat at the moment, so let's carry on and take a look at the final contract here. So taking a look at the egg vault, we can see that this is an ownable contract. It's an ownable contract, and then reference to the Eggstravaganza NFT contract. We then have two mappings. So we are going to be mapping to track the deposited eggs. So we'll be taking the token IDs and then returning the deposited status. So if we have 10 tokens that are minted, we should be able to put into this mapping number 3, and we should be able to see true or false. Has this been deposited into the vault or not? Through this mapping. We are then going to have another mapping to record who deposited each egg. So if token number 3 has been deposited into the vault, we should be able to put number 3 into this mapping and get out the address of the depositor, the token owner. Next, we are going to define some events here. So we've got the egg deposited event and the egg withdrawn event. We are going to be omitting the addresses of the depositor and withdrawer and the token ID as well. So the ID of the egg NFT. Starting off with the constructor, all we are going to do here is define the ownable. So we are going to say that the message sender, the deployer of this contract, is the owner, and they will have the special rights to call some of these functions that have the only owner modifier on there. So with the first function here, we've got the set egg NFT. So this is, once again, only allowed to be called by the owner. And this is going to set the egg NFT address to egg NFT address that has been defined earlier. We are then moving on to the deposit egg function. So this records the deposit of an egg NFT. The NFT must already have been transferred to the vault. So what we are looking at here is we are requiring that the owner of the NFT is the address sender. So NFT not transferred to the vault. Otherwise, this is why this is put in place. The NFT must already have been transferred to the vault. And we are then going to require that the stored eggs token ID has not already been deposited. So we want the stored eggs mapping, which we discussed up here, to return false, and then we can continue. So we are then going to change it to true. Now we are actually following through with this process, and we are going to set the egg depositors token ID to depositors, meaning when we have this mapping and we input the token ID, the output, the address of who deposited the egg, is the depositor, the address depositor from this function. Next, we are moving on to the withdraw egg. So this allows the depositor to withdraw their egg from the vault. We've got a couple of require functions here. We are going to reset some of our mappings earlier discussed as well. So with stored eggs, if we are withdrawing token number 3, we want to make sure that when we have stored eggs and we input number 3, the Boolean now comes out false. So that is changed through this line here. And we want to delete egg depositor's token ID. So this is the mapping to record who deposited each egg. If we have deposited token 3, then we want to be able to input number 3 to this mapping and not get a result from this because the token hasn't been deposited into the vault anymore. It's been withdrawn. We are then going to transfer the egg NFT out and omit the event. Now, final function here is egg deposited. This is just a view function. This is going to be a view for the mapping, the stored eggs mapping. So this will take the token ID of an NFT and return true or false as to whether the egg has been deposited into that vault. So that is the end of the contract walkthrough. Pretty simple contracts here, but there are some vulnerabilities to be found. So it's definitely worth spending the next week. If you've just come out of Updraft, then it's perfect to do this. Just spend the next week reviewing those contracts and seeing what you can find. I think it's really valuable as somebody who has come out of Updraft to just go through these kinds of competitions, because the real skill when it comes to bug hunting is to be able to understand the intended functionality of lots of different contracts and protocols and looking how the functions and the contracts work together. So looking at these simpler protocols and contracts will allow you to learn how to understand different functionality and become more familiar with learning about different functionality and different logic, so that when you do move on to those competitions, you'll have those skills and you'll be able to earn some of those prize pools. Now, in terms of submitting the vulnerabilities on the CodeHawks platform, all you need to do is head to the competition page, hit submit a vulnerability, and you will be taken to this page that gives you a space to put a title for your submission, some information about your submission, the impact, the tools used, and the mitigation recommendations there. Once you've completed, all you need to do is submit your vulnerability, and it will be reviewed by a judge once the competition has ended next Thursday. So when it comes to the first flights, the competitions follow the same structure as a normal competition does. You will submit your vulnerabilities. Once the competition has come to an end, one of our judges will go through the submissions, validate them, and categorize them low, medium, and high. And the better your submission, the more points you will get. So if you are taking part in this competition, good luck. And if you are taking part in these with the hopes of becoming a security researcher and entering some of our competitions on CodeHawks, then do know that we have a lot of exciting competitions coming up. Currently, we have Starknet Staking Part 2 live, and that launched yesterday. This will be live for another 3 weeks. This is a Cairo competition, but in the next couple of weeks, we'll be seeing a whole lot more competitions hitting CodeHawks. So definitely stay tuned and take this time as an opportunity to upskill and learn with those first flights before we move into those real competitions. But that is all we have time for today. So thank you so much for tuning in. As always, I hope you have enjoyed. I hope this has been helpful. If you have any questions about the contracts in the competition, then please head over to the Discord, which is linked in today's description. There is a channel open specifically for this competition where others who have just finished Updraft or finished self-teaching themselves, others who are learning and want to get in the competitive space are within that channel. So you can ask questions about the repo and you can answer questions about the repo and help others in the community. It's the best place to learn. So definitely get involved over on the Discord. But that is all for today. So thank you very much for tuning in as always. And I will see you again here in 2 weeks with another first flight competition. Thank you very much for watching and good luck.